I would like to welcome you to the presentation of the FC103 refrigeration wizard. What we have here is a refrigeration rig. At the top, in the white boxes, you will see some evaporators. Just below, at the back, you will see a condenser, and at the bottom you will see two blue compressors that will compress the refrigerant. If we move a little bit closer, you can see on the right that we have a lot of pressure transmitters. These we use to measure the pressure of the refrigerant, and the drive will by default turn the pressure into a temperature you can use as your set point. Now we move a little bit closer, and you will be able to see that these pressure transmitters are from Danfoss, and it's a little hard to see the values, but these are from 1 to 34 bars, and the control signal is 1 to 5 volts. We also have a low pressure part of the system, which we will see here. And you can see that these go from 1 to 12, and the control signal is also 1 to 5 volts on these drives. Now we will switch to how you actually set up the wizard. Now, here at the back of the refrigeration rig we have 3 drives. One controls the compressor, one controls the condenser, and the last one controls the evaporator. We'll just move a little bit closer, and I'll show you how easy you can set up the compressor by using the refrigeration drives built in Wizard. The other 2 drives have already been set up for this purpose, so I'll just show you how easy it is. The first screen that you will be met by is OK, press OK to run the VLT drive application guide. So this is what we'll do. Alright, I'll press OK, and it says welcome to the VLT application guide. So I'll press arrow down, and you shall now select your application. In this case the default application is compressor, so that's okay, we will leave that. We'll move down. Now it'll ask you to enter your motor voltage. In order to do that, you will need some information from your motor manufacturer or from the compressor manufacturer. I have these values available on the sign just down here. You can see the voltage is 414 volts, the motor current is 11 amps, the nominal speed is 5290 RPM, the minimum frequency is 35 Hz, and the maximum frequency is 90 Hz. This is what we will need in order to set up the motor. Now I'll just program 414 volts, press OK, use the arrows to move down, 1 and 414, press OK, and you move down. The motor frequency was 90 Hz, so we go for 90. Go down. The motor current was 11. So there we go. Okay. And the nominal motor speed was 5290. So there we go. Arrow down. And the minimum frequency was 35. Press OK to that. Go down to the maximum frequency, which is supposed to be 90. Okay. And we move downwards. Now we can enter the recycle time between starts. So this is the time from start to start of the compressor. So this is a value that is fine for this particular application, but is also there to protect your compressor against unintended starts. So we leave this at 6 minutes. Does the application include a bypass valve? In this case, no, but you can also choose yes. Then we are asked, do we want to use internal or external control? We would like to use the built-in PID control. So based on the inputs we get from the pressure transmitters we saw previously, we will regulate. So internal control it is, OK, and arrow down. The sensor type is pressure transmitters and we are using bars. Arrow down, and in this case it's the low pressure part of the system, so it's -1 to 12, and our control or the sensor signal is 1 to 5 volts. So press OK to that and go down. Now the drive tells you how you should connect your 1 to 5 volt signal from your pressure transmitter. This can also be found in the manuals for the refrigeration drive. But we press arrow down and we move on. So now we can select our unit for our set point. So we can choose either degrees Celsius or Fahrenheit. We will choose degrees Celsius. And now we must also select the refrigerant, so the drive will know which pressure corresponds to which temperature. In this case, the refrigerant is 404A, but the refrigeration drive has up to 30 built-in refrigerants. Press arrow down, and we are asked, do we want to use a fixed or a floating set point? We'll go for the fixed set point, and we will enter the set point. In this case I will go for -5. Okay with that. We'll move down. Then we are asked for the high and low set point limits. And these are the boundary conditions in which we can operate. So I will leave them alone. And now we are asked to enter the cut out value. I'll put this at -10. The refrigeration experts will usually know these values of which the system is designed to. And the cut-in value is 0 degrees in this case, and I will leave that as well. Then in this case we do have 2 compressors in the system. So this is what pack control means, that you can control up to 3 compressors. And you're now asked, do you have more than 1 compressor? Or do you wish to configure pack control? We'll say yes to that. Okay. Arrow down. How many compressors do you have? We have 1 variable speed and 1 fixed speed. So 2 compressors it is. And now the drive tells you, where should I connect my fixed speed compressor? And this should go to the relay 1 and 2 on the terminals 1 to 6 found at the bottom of the drive. I'll press OK, and we have now set up the compressor. So arrow down, and now you can choose between rerun the wizard, go to main menu. This is what we'll do, and I will hit status. You can see in the top left corner our set point is -5 degrees and the actual temperature is measured as -15. So now we have finalized the setup of the drive for the compressor, and we went to the status screen. So in the top left corner you can see that the set point is -5 degrees. The current temperature is 11.7 degrees Celsius, and on the right you can see the current that the motor draws. And in the middle you can see compressor 1 and compressor 2, and none of them are running. So I'll just move down here, I'll press auto on, and the drive should speed up. It will quickly hit 35 Hz, which is the minimum speed. It will stay here for a little bit of time, and then the internal PID will make sure that it ramps up to try and hit -5 degrees. See, now the drive ramps up, slowly picking up speed. You can see the temperature is decreasing. and slowly and surely it will move its way towards -5 degrees. And now you can see we are approaching 5 degrees minus, and the drive will try to stay there. But if the heat load changes, meaning that the temperature will increase, the drive will pick up speed and make the compressor work harder in order to try to bring the temperature down to -5 degrees again. And it will also switch on the second compressor by default. I'll switch on the other compressor when the need is there, and then the speed will be reduced of the first compressor in order to match the demands. So what we see now is that the set point is still -5 degrees, but the compressor is working at 85 Hz and the temperature is about half a degree minus. This means that the load has been increased on the system. So now the compressor will hit 90 Hz, which is its maximum. It will stay here for a little while, and if the temperature doesn't decrease enough, it turned on the second compressor. And now you see this is indicated by an R next to the second compressor. So now the fixed speed compressor is running at full speed, and the drive will control the variable speed compressor, so it will bring the temperature down to the -5 degrees our set point is.